Hi, this is Annie and Caroline, and today we're going to teach you a four-step problem in chemistry, and we're going to estimate the average atomic mass first by looking at the percent abundance for each isotope of argon. Okay, so first we have argon-36, argon-38, and argon-40. Argon-36 has a mass of 35.97 AMU and a percent abundance of 0.337%. Argon-38 has a mass of 37.96 AMU and a percent abundance of 0.063%. Argon-40 has an AMU of 39.96 AMU and a percent abundance of 99.600. So the first thing you should do is look at the percent abundance and find which isotope with the greatest percent abundance is, and that's clearly argon-40. Then you should look at the other isotopes and decide if their percent abundances raise or lower the average. So as you can see, argon-36 and argon-38 are going to lower the average slightly. So we can conclude that the average atomic mass should be slightly lower than argon-40. So what our estimation was is that it should be 39.8 AMU.
This is Caroline. Now we will calculate the average atomic mass. I'll first give you an overview. This is argon-36, argon-38, and argon-40. This is the decimal form of percent abundance of argon-36 as well as its mass. You multiply these two together, and you do this for each isotope. You do that for argon-38, this is the decimal form, and this is the mass, and argon-40, this is the decimal form, and this is the mass. Then you add all three together and receive your average atomic mass. Now I'll take it slower. You take the percent abundance of each isotope and put each percent in decimal form by moving the percent 2 places to the left. It has already been done. Now that you have the decimal form of each percent abundance for each isotope, you multiply each individual isotope's mass in decimal form of percent abundance, and then add all three together to receive and calculate the average atomic mass. Notice that our original estimate was close to our actual average of atomic mass.
Yay!
Caroline again. Next we will determine the number of protons, neutrons, and electrons of each isotope, argon-36, 38, and 40. To determine the number of protons, you simply look at the periodic table in the atomic number, which is the number of protons, located above the symbol for the element argon. So the number of protons in all the isotopes of argon-36, 38, and 40 is 18 protons. Since atoms are neutral, they have the same number of protons and electrons, so the number of electrons for each isotope would also be 18. To determine the number of neutrons in each isotope, you subtract the atomic number, 18 from all, from the mass number. For example, the number of neutrons in argon-40 would be 22, since you simply subtract 18 from 40. So there are 18 neutrons in argon-36.
Make a Bohr diagram for argon-40. Okay, so you put the protons and the neutrons in the middle of the Bohr diagram since they're in the nucleus. And then you're going to put the electrons on the energy levels. So on the first energy level, you're going to put two electrons, and they have to be paired up. On the second, you're going to put the electrons, and there are going to be 8 of them. The first two that you put on have to be paired up, no matter what. And then you put on the others, and those happen to be paired up because they're full. And then the second is exactly the same.